Hi everyone, I am Ilaf Ahmed from Nahran University from College of Information Engineering from Iraq. The research title is Creative Distinctive Databases of Ancient Language and using a computer vision model to accurately recognize and classify them. All the authors from Iraq, from Nahran University and from Baghdad University. The agenda of the presentation, first of all, introduction, and then motivation, database preview. We talk about the value of the data, and then data set labeling. After that, we talk about how to make a data enhancement for tool language. The model, we talk about the yellow model, proposed model. After that, the experiment results, and the final thing is the limitation and future work. Ancient language, such as cuneiform and Hebrew, are the key to understand early human civilization and communication. But deciphering this script is often slow and depends on the specialized with deep linguistic and archaeological expertise. So, in recent years, computer vision and deep learning and emerges a powerful tool to analyze and interpreting ancient symbols. So this research introduced a novel framework that combined data creation, annotation, and yellow-based recognition to automate the reading of ancient signs. So the main objective of this research is to create two comprehensive datasets, one for cuneiform tablets and another one for Hebrew manuscripts, and to train by using deep learning model to make recognizing and classifying these ancient language. The motivation to make this research, the first one, the preservation of cultural heritage through digital recognition, to ensure that ancient scripts remain accessible for future generations. Also, the damaged or incomplete tablets that make major challenges for manual identification and analysis. Also, overlapping Hebrew character in this increased complexity in segmentation and symbol separation. And the limitation labeled data make training by using deep learning model more difficult and less accurate. So we make this research to build a scalable and reusable datasets to enable AI-driven interpretation of ancient text efficiently. The datasets that was collected, that consists from two datasets. The first one consists from cuneiform tablets, gathering from Iraqi Museum and CDLI website. This website consists from many tablets for different dialects of ancient language. We go to the Iraqi Museum and take different language for 14 tablets. These tablets for Assyrian language. So this dataset is the first dataset that covers from three main dialects: Assyrian and Sumerian and Babylonian. The Assyrian is consisted from 3,271 image, and Sumerian consists from 1,435, and the Babylonian consists from 1,321 tablets. So this is the first dataset. These images show different tablets from Iraqi Museum. These tablets for Assyrian, New Assyrian dialect. The second dataset is for Hebrew secrets. It's selected from two sources. The first source is for all the statement sources, the old books that's written by Hebrew language, and the second one is for the new Iraqi discoveries. This old document that discovered in the north of Iraq in the 2024 year. So we use this new discover, this old document and the old books to collect the sign or character of the Hebrew language. This dataset that reach around 1000 images after augmentation. These two datasets that was published in the Mendeley data with public access. These many samples for Hebrew language. As we see, these samples from old books and from the old document that was discovered in Iraq and from different secrets that was published in the different websites. The value of these collected datasets. The first one, this dataset can facilitate translation, interpretation, and linguistic conversion among ancient secrets. Also, this dataset can serve as a benchmark dataset for machine learning model in archaeology. Also promotes the digital preservation of cultural heritage artifacts. Finally, openly available for further research, collaboration, and replication. After completing the collected of dataset and complete the preparing of dataset, we need to make labeling for the Hebrew letter dataset. The number of the Hebrew letter is 22 letters. We need to make annotation because we make detection of these Hebrew letter on the secret by using pre-training model. So we use RoboFlow platform. This platform that used for annotation, and also we can use this platform for training. But we just use this for make labeling for these 22 Hebrew letters. As we see in the table, these all the 22 Hebrew letters. As we see in the third column, it's the letter's name. The letter's name, this the label that was used when we use the RoboFlow platform. So this letter's name is the labeling for Hebrew letter. And as we see, we write this table by using English language. The complete number annotation that was reached for 21,699 annotation across 471 target image. As we see in the show image, this image class balance after complete the annotation of all image and complete the annotation for all the letters in the image, we reach this the number of annotation for each letters. As we see, the number of image for 471 image and the number of annotation 21,699. The class balance is all the letters is that means the number of classes that was detected. As we see, the first letters that reached to more than 2,000 annotation, and the second one also the more than 2,000 annotation. As we see, the number of annotation that decrease until reach the last letters to 123 annotation. So as we see, this is the number annotation for this data set. and in the future we try to make more balance for the number of annotation for each class. Data enhancement for Hebrew letter. After complete the labeling and collected step for dataset and labeling step, we need to make enhancement for this dataset. This dataset we make enhancement by using also Flow platform. We make a pre-processing and documentation for this image. Pre-processing we use auto-oriented. Also resize this image for 640 by 640 pixel because the yellow version 8 got work for the by using this size of image, and adjust contrast for uniform clarity. Also for augmentation we use rotation between 15 degree. Also we change in the brightness and control the noise to simulate real-world variation. After that we generated more than 1000 image. We separate this image to 88% for train and 8% for validation and 4% for the test. Also for the second dataset that consists from cuneiform tablets that was developed for classifying Sumerian, Assyrian, and Babylonian tablets. Also, we make pre-processing and documentation for this image. As we see in the table, the total number of image for each language. For Sumerian that reach 1440 and for Assyrian that reach 1330, also for Babylonian that reach 1330. And also we separate this image for train validation and testing. 70% for training and 15% for validation and testing. Also, we make pre-processing. We make normalization for the image and noise reduction. Also, we using augmentation. The augmentation box we use rotation and flipping. A proposed model for classification and detection model. We use the same model for classification and detection. This is the yellow version 8. But the difference between the classification and the detection, as we see, for detection we need make labeling for images with the 22 categories. These 22 Hebrew letters. So this is the number of classes that we need to detect. After that we make pre-processing and documentation. This is the second step after making labeling. After that we input these images to the yellow version 8 to make training for this custom dataset. After that the output of the yellow, this is the detection. The detection is to make the round box around each letter, and the label of each box is the letter name. As we see in the previous slide, this letter name that was right by using English language. Also the same thing for the classification model. After that, as we see, we integrated the API Google Text-to-Speech (GTS) to pronunciate the Hebrew sample detected by the model, and also for pronunciate the correct answer of classification. Also, this the detection, the result of the detection, as we see the detection of the letters of the Hebrew. and the higher accuracy, the average accuracy that was reached 92%. Also, this the result for classification model. The classification model that reached the 100% accuracy. Also for that was reached for top 1 accuracy 96% and top 5 100%. This is the result for classification model. As we see, this the classification, the higher probability for the correct answer. The first image 100% for Sumerian and 85% for Sumerian in the second image and 100% for Assyrian in the third image. These present the result of the test of the classification model. The future work on limitation. The limitation is still the data size is the limitation in the size of the data set. Also, the tablet has degradation effect. We need to use more clarified tablets. In the future work, we need to make expand for the data set. Also, use another model and another algorithms to make training and to enhance the training and to enhance the result and develop a cross-equal recognition framework for multiple ancient language. Thank you for listening.